Welcome to the first of a series of podcasts about interesting and spectacular demonstrations in chemistry and how to do them safely. For the first one, I've chosen the Howling jelly baby experiment, which is really the oxidation of gelatin and sugar with potassium chlorate. It's spectacular, but it can be demonstrated very safely if you just follow a few simple instructions. Let's talk about the safety issues first. This is not covered by the standard safety assessment which most school laboratories use. This isn't particularly a problem because there are specific safety assessments for this on the web, and you can possibly collaborate with your local authority or with CLIAPS in order to get a specific safety assessment written for it. Now, the oxidation products in this reaction are nothing but carbon dioxide and water. So despite what you might read or be told, there is absolutely no need whatsoever to carry out this demonstration in a fume cupboard. The products are perfectly safe. Now, in order to do it safely, you need a 25mm test tube, the thing that's normally called a boiling tube. And it should be borosilicate glass, Pyrex, so that it is effectively heat-proof. In order to cause an explosion, you need two things. You need a very large amount of gas to be produced very quickly, and you need to confine it so that pressure builds up rapidly. Now, in the case of this experiment, a very large amount of gas is indeed produced quickly, but the use of the wide-mouthed tube with obviously no stopper means that there's no build-up of pressure. So there is little danger of explosion. The clamp that you use should be one that does not have rubber on the jaws. There have been a number of problems reported. The tube does get very hot and rubber can melt, and it's not a good thing. So use a purely metal clamp or a cork-lined clamp. It is obvious, I think, that the tube should point away from pupils. That's not a difficulty. As you'll see in the demonstration, the tube points to the side, the pupils will be in front of you. Probably the greatest risk attached to this experiment is actually the test tube cracking, which will shower the demonstrator with molten potassium chlorate. And that really isn't good. It will land on your skin and it will carry on burning until it's really quite a long way inside, and that really isn't good. So the demonstrator should wear eye protection and should wear a reasonably heavyweight leather glove on the hand that's close to the test tube at least, in order to minimise any damage that cracking may cause. Having said that, it really shouldn't happen. It's a remote possibility, but you must be prepared for the remote possibility. In terms of safety screens, because mostly of the possibility of tube cracking, you should have a safety screen between the demonstration and the pupils, and as well as ensuring that the tube is pointing away from the pupils, you should also have a safety screen at some distance away at the end of the test tube in order to catch any molten potassium chloride that's ejected during the reaction. For the benefit of this video, we shall not be using safety screens. I should be wearing the appropriate personal protection equipment, but we won't be using safety screens because only video cameras are involved. There is no pupil audience, but you must not do this without a safety screen. That is very important. And also make sure that no pupils are looking round the safety screen. This is something that frequently happens. The safety screen gets in the way, they'd like a better view, so they peer around it. Make sure that they're not doing. To do the demonstration, you should first of all lay out some heat-proof matting. That will protect the bench against any splashes of molten potassium chlorate. Retort stand and clamp. As I said previously, the clamp should not be rubber. For the purposes of this demonstration, so that the camera can get a good view, I'm going to do the demonstration effectively the wrong way round. It doesn't fall naturally to me, but it will make a better view for the camera. When you do this, you must make sure that everything is arranged so that it falls conveniently and naturally to hand, whether you're right or left-handed. So we take the retort stand and clamp, we take our boiling tube with about 10 or 15 grams of potassium chlorate in it. That's about 2 or 3 centimetres. The potassium chlorate really should be new or recent stock because oxidizing agents age treacherously and can give very unpredictable results, which is not a good idea at all. So that is clamped up as close to the mouth of the tube as we can at an angle of about 60 degrees. As I have said and will say again, safety screens should be here and here. Protective equipment for me, the leather glove, the eye protection. Now, this is the star of the proceedings, the jelly baby. Why a jelly baby? One, because it gives an extra dimension of sadism as this poor innocent creature is sent to its doom, but mostly it's because the structure of a jelly baby is amorphous. There is no crystal structure and it has a small surface area. That will ensure that the reaction takes place vigorously but not dangerously. Were you to use something like sugar, which is crystalline with a large surface area, you would possibly find that the result in reaction was unacceptably violent. So, jelly baby. So we now melt our potassium chlorate. It's important to ensure that the potassium chlorate is thoroughly molten. If it's only just on the turn and just melted, when you put the cold jelly baby in, potassium chlorate will crystallize around it, and this has before now been known to cause the jelly baby and some of the contents of the tube to be ejected, and that is really not a good idea for this demonstration. So make sure that your potassium chlorate is not just melted, but is thoroughly melted and is hot. I think that should just about do it. So now we take our victim. Don't forget to ask whether the victim should enter the tube head first or feet first, and your pupils will always say head first. So that's what I'll do. In it goes. So that's the demonstration. I hope you'll agree that it is both spectacular and, done carefully, safe. Why is it called the Howling jelly baby? Because sometimes the emission of gas is accompanied by a musical howling sound. That happens because of the vibration of a column of air in the tube, in much the same way as blowing across the top of a milk bottle or playing a flute produces a vibrating column of air. Now you can use this experiment, demonstration, lots and lots of times. It can be used when you're discussing oxidation. You will notice the very obvious lilac flame colour. It's a very good way therefore of showing the flame colour of potassium, which often doesn't work on wire flame tests because it's masked by sodium. And of course you can always use it as an end of term or end of topic treat or something to amaze and amuse parents on open day. So there are lots of excuses for doing this, and I hope you'll try it.